So today we will be talking about how to remove TLE and how to optimize your code. Like when you are in coding interview, suppose you are writing a code for n square, or you have the logic for n square, which is of complexity n square, and the interviewer wants you to improve. So what are the things that you should look at and how you should actually improve the code? Okay, and suppose even the interviewer says that okay, this is good, you should always think that is there a better way. So let me give you an example. So suppose first of all, I will just clear one thing, like for 1 second you can approximately have 10 power 8 operations. Okay, so uh, you should always keep this in mind. Like suppose if you are given like n is equal to 10 power 6. Okay, means we have an array and here n is equal to 10 power 6. Something like this is given in your coding note. So you should not think of a logic like which is n square root n or n square, because this will never work in like 1 or 2 seconds. So basically, whenever you are given the constraints, you should always first decide the complexity. Like at most till this complexity I should go. Like if 10 power 5 is given, mostly the solution is n or n log n. And something like if 10 cube is given, in worst case it will be n square root n or n square. So these are some of the things that you should keep in mind. So do you want me to repeat this thing, or you understood this one? Like this were just some facts that I stated. Okay, so see, you should always remember that if you are given the time limit as 1 second, so 10 to the power 8 operations can be performed in 1 second at the best, but you should never take it to 10 power 8. It should be like something around 10 power 7, means less than equal to 10 power 7 is good enough. Okay, and then when you are given the constraints like 10 power 5, so you should think like n or n log n solutions. This is not compulsory, like it will always be n or n log n. It can be a lesser complexity solution, but at worst you should have these two complexities in mind. And for like 10 cube, n square root n or n square, something like this. So these were some of the things that you should know. And now let's start with one thing that suppose you are given two elements, okay, A and B. And now there are two players. Uh, let's take them capital A and capital B. Okay. Now we are playing a game and A will start always. And what are the moves in the game? The move is you will take the first element, decrement it by 1. So if I am having A here, I will decrement this by 1 and I will swap the values of A and B. Okay. So now suppose I am having the values like A is 10, B is 8. Okay. So now if it's A is done, what A will do? A will take the value and decrement it. So it became 9, 8, and now swap the values. So now the values of A and B are 8 and 9. Yes. So see, now this is the move. Now after A, it will be B's turn. So now what B will do? B will decrement the value of first element. So now elements became 7 and 9. And after this, it will swap the elements. So it became 9 and 7. So in this way, the game will go on until the player who is not able to perform the move, means if we find a player who is not able to perform the move, he will lose the game. And how we will decide that the player is not able to perform the move? That means if we get the value as 0 here, so now if the user will decrement this value, So it will become -1, which is negative. So if the user who gets this move will lose. Okay. So we just have to tell whether A won or B won. So now we will start thinking like what we can do. So one thing is we can just apply what is given. Like I will keep applying the operation until A is greater than 0. Okay. So I will write like while A is greater than 0. What I will do? I will decrement A by 1. I will swap the values of A and B, and I will count also, like how many operations are performed. So on the basis of count, I will say who won or and who lost. Okay. So this is one solution that you can use. Okay, we will use C for the count. Now, this code is good. This will work. But what will happen here? If my A and B values, they are less than equal to 10 power 5, means if they are greater than equal to 1 and less than equal to 10 power 5. This will be the case where this code will work within 1 second, because we already know that in 1 second 10 power 8 operations can be performed, right? So if A and B are less than equal to 10 power 5, then how many operations will be performed at worst? So let's say that both the values are 10 power 5. So every time we are decrementing the value and we are swapping it with B. So first A will be 10 power 5, B will be 10 power 5, then A will decrement and we will swap. So 10 power 5, 10 power 5 minus 1. So it will go on like this and we will perform 2 into 10 power 5 operations, right? This is clear to everyone? 2 into 10 power 5 from where we are getting this value. So uh, if you will compare this, so it is workable in 1 second. Okay. But now what if I say it is not 10 power 5, it is 10 power 9. So now what you will do? Like, you know how many operations will be performed at worst? Like it will be 2 into 10 power 9 here. If A and B values can go up to 10 power 9. So at this point, you will have to optimize the code. Okay. So to optimize the code, what are the things you should look at first? The first thing is, do you actually need to perform the operation? So what do you all think? Do we actually need to perform the operation? Hello? Yeah, we do not need to perform. See, what is happening? If I'm having AB values as 101 and 102, and I'm having AP values as 1 and 2, I can say both of these are almost equivalent. How? Because at some point of time, when I'm applying this operations on these values, they will become equal to these values, and it will be after 200 operations. Okay, so the values are little bigger. So let's take some lesser values like 5 and 6. We will take 5 and 6. So here the values will become equal after 8 operations. So let's see 5 and 6. So in the first operation, it will become 6 and 4. In the second one, it will become 4 and 5. For third one, 5, 3. For fourth operation, it will become 3, 4. Then fifth, sixth, seventh, and eighth. So in the eighth operation, it will become 1, 2. So again, we are at this step. So you can see that this thing, the values, they won't matter. The only thing that we need is which one will finish first, like whether 5 will finish first or 6. So we are decrementing the value by 1. Okay. So we can clearly see that 5 will finish first. So we can say if the value of A is 5 and B is 6, so who will win? Here B will win. Okay. So whatever code we did right here, we do not need that much. Yeah. So for this whole code, what we can write? We can just write one if, like if A is less than equal to B, we say, uh, sorry, capital A. Okay, we say capital A wins, and else what will happen? Else we can say capital B wins. Okay, is this clear to everyone? Like what we did here? This was just a basic question to tell you like how you should think. Like if you want to, if you have to change the logic. Like see, here what will happen if you're performing the operation? You will see that all the operations are linear time, like a minus minus, swap, C plus plus. So you cannot do anything here if you want to optimize the code. So what you can optimize actually? You can optimize the while loop. And if you can remove the while loop, your code will become constant time because this is the only loop which is taking all the time. Okay. So we did the same thing. We removed the loop and now our code is constant time. So even if the value goes to 10 power 18, this code will work. Acha. So from where this 2 into 10 power 9 came, are you asking that? Okay, so let's move to the next question. And for the next question, we will take this on the screen. So this question is asked in Google. So we will try to solve this one. Okay. So first of all, we will see the constraint. Okay. So yeah. So here are the constraints. My screen is visible, right? So what we are going to do? First, we are going to see what are the constraints. So it is 3 into 10 power 3. So it is actually means comparable to 10 power 3. So what are the things that we know? If constraints are equal to 10 power 3, we should think of n square root n solution or n square solutions. Okay. So let's start with the brute force solution. Okay. So for brute force, the question is quite simple. See, we are we just need to find a person who knows all, but who all knows, but he doesn't know anyone at the party. And how we are going to get the information? So it will be an n cross n matrix where n is the number of people, and if the value is 1, that means the ith person knows the jth person. Means, see, if this value is 1, that means the person which is at 0. Okay, so I will explain it here. So see, if you are having a matrix like this, and we have two persons because it is 2 cross 2 matrix, we have two people. So let's give them indices like 0, 1, 0, 1. So this is 0th person, this is first person. So here, for the first person, this value is 1. That means he knows 0th person. But for 0th person, both the values are 0. That means he doesn't know anyone. So here, 0 is the celebrity because he doesn't know anyone. But everyone other than this person knows him. Like we only have one and one knows him, but he doesn't know anyone. So he is the celebrity. So one approach is for this one. Uh, actually, uh, do will you like to be? Do you like? Would you like to solve the problem? Anyone? Or just approach like it? It can be any approach, brute force or anything. We just want to do what the question states. We just have to find the celebrity and under any complexity solution. See, the question is we are given a matrix. We are given a matrix in which is n cross n, where n is the number of people we have, and if the value is 1 at any point, suppose for the ith row, jth value is 1. That means this ith person knows the jth person, and if the value is 0, that means this person doesn't know who the jth person is. Yes, you will be have we will share the recording with you, and we have to find a person I such that all the values here are zero. That means he doesn't know anyone, but all the values other uh, for other people. Like if this is some kth person, so ith value here it should be one for everyone, like one, 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 like this. Okay, we have to find this person. If you want, you can also read the question. Just search celebrity problem and you will get it on GFG. Yeah, row zero and column zero. Yeah. So let me just share one thing. Like for this one, we can we can just write the complete brute force and we will check whether that works or not. Okay. So we have a matrix, we have n people. So let's check if the ith person is celebrity or not. So we will go for every person. Since we have n, so we will go from 0 to n minus 1. And then what we will do, we will check that all the values should be 0. Only the means all the row values should be 0 and all the column values should be 1. And the intersection should also be 0, right? Because if I comma I means this person knows the same person. So this thing they have always set it to false. Means logically it should be 1, but they have done it. So we cannot do anything. So let's check. We will have one boolean value which will be set to true. Means currently we are assuming this person is the celebrity. Okay. Now we will check for all the values. Means all the rows, columns. So if I is equal to j, means its intersection, then we don't have to do anything. So here we can write continue. But we have one more option. Instead of writing continue here, we will just write if I is not equal to j, then we will do the steps which are further. So we will check what that the row should be 0. So if m of I of j, this should be 0. Means this person should not know the jth person. Okay. Uh, and jth person should know the ith person. So m of j of I, this should be equal to 1. So these are the conditions that we want. And if this is true, then we are okay. Like we can say that till this point, this particular person is the celebrity. Okay. And we are currently assuming that this person is a celebrity. So what we want? We want a condition where this condition is false. So we will use a not to take the negation. And if this happens, we will say that is equal to false. That means this person is not the celebrity, and we will break the loop. Okay. And after breaking, we will check. If okay, that means the person is celebrity, we will return I, and if it is not, we will check for the next person. And if after performing means after checking for all the people, if we get that not a single person was celebrated, we will return -1. Okay. No, it can be anything, but they have mentioned that they will give it as 0. So everyone is okay with the code, like what I have written. Did you guys understand it? Yes. So see, this is a n square complexity solution. As you can see, we have one loop And inside that we have another loop which is running for r n times. So first loop for n times and another loop for n times. So n square solution. Okay. Now let's check whether this will run or not. Yeah. So if we submit, we are getting problem solved successfully. But if the interviewer says to solve this problem and you got the solution, so can you think of something which you can improve here? Like in this code, is there something that you can improve? Because see, here they are expecting you to solve it in n square and constant space. Okay. So we have done that. This is n square solution and we have just used a boolean value. Okay. We are not using anything else. So according to GFG, this should be good enough for you. But if if a Google interviewer is asking you the solution, isn't it quite easy to solve? So let's see how we can improve this one. So first of all, what are the things that we should try to improve? First of all, we will try to improve loops. Okay. So we have two loops here, the first one and the second one. And in the second loop, we are checking ij and ji. So what if I say, okay, I will explain it here. In this code, what is happening? We are checking for every value. Okay. So we are once going in the row. So for the entire row, we are checking all the values. And for the entire column also, we are checking all the values. And what every row means, every I comma jth block, jth value, what it tells us. If this value is 0, that means this person can be celebrity. Okay. Is it okay or not? No. We cannot use binary search here. We will solve it in linear time. We will not use n square solution. We will solve it in linear time. Okay. So if the value is 0, then this tells us that this person can be the celebrity. But what if this value is 1? What this tells us, this person knows jth person. So jth person can be celebrity, not this one. So if the value is 1, that means this person is not the celebrity. Okay. So how we can use this data? So if we are given any value in the matrix, so we will check two values. Okay. Means we will check one by one. So first of all, let's say that we have all the values from 1 to n. Okay. So our L will be here, our R will be here. We will use two variables, L and R. We will set L is equal to 1, R is equal to n. Here I am assuming that it is 1 based indexing. Okay, let's not do that. Let's assume 0 based. So 0 or n minus 1. And the values here will be L is equal to 0, R is equal to n minus 1. So now we have values something like 1, 0, 0, 1, 1, 1, and then 1, 1, 1, 1. Yeah, this will be 0, this will be 0 because I combine, and this thing. So here you can see this person is the celebrity. So we should get 2. So how we will start? We will check the position at L comma R. So 0 comma n minus 1. Here our n is 4. So R will become 3. So 0 comma 3. And this value is 0. That means the ith person, means for I we are using L. Okay. So this person can be the celebrity. because this value is 0. But this person cannot be, because this particular Lth person doesn't know who the Rth person is. So what we will do, we will remove R from our list of celebrities. Like this person cannot be the celebrity, so we will remove it. So we will do R is equal to 2. Means we will decrement the value of R. And now we will again check for 0, comma 2. Yeah, for 0, comma 2, the value is 1. That means this person knows who Rth person is. Okay. So if this person knows who Rth person is, this person cannot be the celebrity. And if he cannot be the celebrity, what we will do, we will remove him from our uh, celebrity list. Okay. So we will increase the value of L. So now 1, comma 2. Now we will check for 1, comma 2. So for 1 and 2, what is the value? Value is 1. So again, the Lth person knows the Rth person. So we will check whether, means we will increment the value of L because L cannot be the celebrity then. So again, from 1, we will increment it to 2. Now what we got? We got L is equal to R. That means we only have one person in our list, which is the second person. So we will only check for this person whether this is the celebrity or not. And if this is the celebrity, this will be our answer. And if this is not the celebrity, then we will not have any celebrity in our list, in our entire group of n people. Okay, so did you guys understand the logic what we are doing with this L and R? I will explain it to you again. So see, this time we will go a little faster. We are using the data that is given. Okay, so the data given is if the value is 1, that means ith person cannot be the celebrity, means I means the first index, means 0. And if the value is 0, that means jth person cannot be the celebrity. So we are using two variables, L and R. Okay, so we will use ij only, means we will use I and j, and we will set them equal to 0 and n minus 1. So currently we have all n people in our list of celebrities. And now we will check for 0 and n minus 1. So for 0, n minus 1, what is the value? It is 0. So if the value is 0, that means jth person cannot be the celebrity. And here we have 4 persons, so this value will be 3. So jth person cannot be the celebrity, so remove it. So if I remove this person, I should go up because that is the last person for me now. So 0, comma 2. Then we will check for 0, comma 2. What is the value? Value here is 1. So if the value is 1, this means that the ith person cannot be the celebrity. So I will remove the 0th person. So I will remove this person, and then this first person now is 1th person. So I is equal to 1. And again I will check this value is 1. So again I will increment the value of I. So it became 2. Yeah. So now I think it is okay for everyone. And at last we will check the person which we are left with, whether this is the celebrity or not. If this is the celebrity, then we are done with our problem and we got the celebrity. And if this is not, then we will return -1 because we cannot have the celebrity there. Okay, so let's try to code this one. So we will check I is equal to 0, j is equal to n minus 1. Now after this, we will check until I is less than j. That means until we have more than 2 people, means more than 1 people in our list, till that time we will check. And what we will do, if of I of j this is equal to 1, that means the jth person, means the ith person cannot be the celebrity because this person knows jth person. So we will do I plus plus. else we will do k plus plus. Sorry, k minus minus. This we will we will be left with only 1%, which is I. So for that, we'll check all the values. So we already have it. So here is that k plus plus. If of I of j equal to 1 or m of I equal to 0. In this case, we will return minus 1. This will return. That is running or not. So here it is running. So I j I 0. Okay. So we should only take this when I is not equal to j. At that point, we will this with I not equal to j, and then this condition should be true. Now if we submit, so we get all this is passed, and this is of n complexity solution with constant space. So the interviewer is expecting this if we ask this question to you. So even if it is given like n square, the expected time complexity is n square. You should always try to optimize it till the point you can. Okay. Did you guys understand the method? We also have one different question, but there are only 50 students, I think. So anyway, let's see that question also. So see, what we have here is we have some train arrival and departure system where we need to find the minimum number of platforms that are required for the railway station such that no train is kept waiting. So see, this question will be something like I will explain you the logic and you should try to code it yourself. Okay. So I will explain the question here also. Like you are given two arrays here, two arrays of size n. One is arrival and one is departure. In the arrival, you are given the arrival time of all the trains like A1, A2, A3 like this. And in departure, you are given the departing time of each train. And no two train can have the same. Like if you have only one platform, then the train which is going to go at exact moment, then any train which is arriving cannot arrive at that moment. Okay. So if this is the case, like a train is going at X and one train is arriving at X, so we will need at least two platforms, one for the arrival and one for the departure. Okay. So this way two arrays are given, and you just need to find the minimum number of platforms you will require. Okay. So in this question, there is one thing to find the minimum. All you need to do is at one moment, how many train can be present at the railway station. You just need to find that, and that will be your answer. Okay. So suppose at a particular moment, five trains are waiting at the station. So you will need at least five platforms, And similarly, you will check for every moment that whether means how many trains are there, and you will take the max of it, because at one moment we have one train, at one moment we have five trains. So we cannot say that we will need one platform, because we will need five platforms here. Okay. And for this, there is one solution which you can say it's like we will iterate over all the moments, like from means you can see here the values can be between 0 to 2400. So we can iterate over all the values from 0 to 2400, and for every value we can check from all n10 n trains which trains will be present, and we can count them. Okay, so this will be 2400 cross n, and let's see whether this is workable in 1 second or not. So n is 5 into 10 power 4, and this is 2400. So you can see this will be something around 24, 5, and 20. So 1.2 into 10 power 8. So see, this is more than 10 power 8. So we cannot do this in 1 second. So we should avoid it. And why do we need this loop? This loop uh, for iterating over all the trains, because we don't know at one moment how many trains will be present. So how we can pre-compute it? Because whenever we have to reduce the complexity, we will remove at least one loop by applying some other laws. Okay. So first, let's see. No, I will just leave the coding part to you this time. What we can do here is we can have the array which will denote the number of trains present at one moment. Okay. So size will be 2400. So we will have something like this, all the values set to 0. And for every train, we will mark the arrival point as +1. So if a train is arriving at this point, I will increment the value of this by 1. So this will become equal to 1. And if a train is going to depart at this particular moment, then till this point, this particular station is means one train was present. So I will decrement the value of the next one by -1. So now if I will take the prefix sum of it, means if I will calculate the sum, so what will happen? This value 0, 0, 1, 1, 1, 1. This will become 0, 0, 0. So now I get all the points, and the number of trains is 1. This denotes that one train was present here, 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 here at this particular moment. Okay. So in this case, we got the number of trains present at ith moment, and for this you will have to run a loop for 2400, means from 0 to 2400 once to calculate the prefix sum, 0 to n to mark all the values, and at last you will again means okay. So while calculating the prefix sum, you can also take the max value. So here it will be 1. So you will need one platform. So this will be big of an time solution. Okay. Did you guys understand this one? Or you have any doubts? Okay, so see, what we are going to do is we are going to have an array which will store, means we will use the index as the time. So here we have the time till 2400, right? From 0 to 2400. So we will start from 0 and we will go to 2359. Okay, and actually here you will have to read some things properly because it is not 2400, it's 24 into 60. So what you can do, you can just add one value, means you can have a prefix a count array, initialize all the values to 0. That means at this moment, not a single train is present. Means at any moment, not a single train is present at the railway station. And when you get the arrival time and departure time, iterate over them from 0 to n. So at the arrival time, we will increment the value of train by 1. So if a train is arriving at this particular point, then increment this by 1 because one train has arrived. So 1. And at what point this will depart? Let's say at this point. So what we will do, till this point we had one train here. So at the next point we will decrement the value by 1 because we will say one train left. So now we have one less train from the previous one. Okay. And after iterating over all the values, what we will do, we will calculate the prefix sum. Prefix sum means for every point, we will add the previous value to it. So now if we will start from this value, so first one will be 0, second one will be 0, third one will be 1 because 1 plus 0, and then fourth one, this value is 0, last value is 1. So here also 1, then this 0 plus 1, this will be 1, and one more 1 will be there, and after this minus 1 came. So this minus 1 and this plus 1, they will cancel out each other, and here 0 and here 0. So we know that from this point till this point, one train was present. So from this point to this point, one train will be present. So now we can get the value of how many trains are present in constant time. And after that, we will iterate over all the values, and we will just say that at this point, this many trains were present, and we will take max of them, and this many platforms will be required. We are trying to find out the minimum number of platforms that are required so that no train is kept waiting. That means at one particular point, if there are 3 trains at railway station, so all these 3 trains should have have at least one platform. So there will be 3 platforms here, like this. Would you like to code this one, or do you want me to show you the code? Okay. What about others? So I think it's almost 8 to 10 minutes. If you're not okay, so you are done. Okay, can you share the code? So I think there is link for the code. Okay, so don't share. I will just code it and show it to everyone. No, no, let it. Yeah. So see how we will go for this one. First of all, what we need? We need an array to denote how many trains are present at one particular point. So we will create an array of size 2400, and this one is just so that if the value is 2359, then we can add -1 to the next value, which is 2400. So it will be one extra value, which we are not going to use actually. And after this, we will iterate over all the trains, since there are n trains, so we will iterate over all of them. And we will say that this particular point, one train has arrived. So how many trains were present initially? We should increment it by 1. So for this plus 1. And how many trains departed at this particular instant? So at the next point, they won't be present. So for this train, I will decrement the value of the next point by 1. And after this, I should iterate over all the values and take the ticket sum of it so that I get all the number of trains at one particular instant. So this is done here. And after this, what I need to do is I need to take the max of all the values. So I will initialize one value which is equal to answer as count of 0 because we are not going to add anything to this 0th index. Means that 0 instance there is no previous instance, so we will not add anything to it, and we will take answer is equal to mix of answer comma count of 1. So for all the values, means for all the instances, we will take the max of answer comma count of I and will return the answer. Let's check whether it is running properly or not. So here the output is okay, and here also all the test cases are passed. Now see here also the time complexity which is given is n log n. So we are doing it in means n is 50,000, but what we are doing it like in big of n because and we have removed the log n factor, and for auxiliary space instead of big of n we have used big of 2400. Okay, so do you guys have any doubt in the coding part? Because this will be the optimized code. You can have the screenshot or whatever you like. Did you guys understand this one? Then you can leave the meet.